with. Okay. Okay. So the next algorithm which we are going to look is Bellman-Ford. Okay. Now again, Bellman-Ford is also a SSSP. Okay. So the intuition of Bellman-Ford is very clear. Okay. So you got the time complexity of this, right? Extra E into log V. Okay. Bellman-Ford is also a powerful technique. I mean, you will never use probably in NEET code because out of 1,000 problems solved, I have never used Bellman-Ford. So I hope you should also not get a situation to use this, but it's very easy again. Okay, it's very simple. So since Bellman-Ford is also a SSSP, which is a single shortest path, why we need to study this? There should be something, right? If Dijkstra already exists, why does Bellman-Ford comes into picture? So there is one good fact about Bellman-Ford is Bellman-Ford can help you to detect this. Okay, Dijkstra cannot detect this because Dijkstra just goes on, and it will go into an infinite loop. But Bellman-Ford will help you to detect, and it will help you to tell whether there is a negative weighted cycle or not. ठीक है? Clear? Is the concept clear?
Yes.
क्या हुआ मेरा आवाज नहीं
Yeah,
आ रहा?
yeah, understood, bro. So it will work in case of negative weights.
No, it will help you to detect. That's all. It can tell you that there is a negative weighted cycle. Okay, nothing else.
Okay,
So
okay.
because you cannot solve that problem, right? Because it's an infinite negative problem. I mean, it will just go on to an infinite negative loop. But
Okay,
it will
okay.
just help you to say that okay, this graph has a problem. That means this graph has a negative weighted cycle. So let's take the same example probably. Okay, and we'll try to run it. I mean, it's pretty straightforward algorithm, nothing else. Okay. So we have some random graph, let's say 3, okay, 3, 2, 1, 1, let's say 10, something like this. And we need to maybe, let's say we need to start from 1 and we need to find the distance. Okay. So what Bellman-Ford does is, Bellman-Ford tells you, go ahead, go ahead with all the edges, whatever you have in your graph, try to relax it. Try to relax it. That's all. Okay. That means ये जितने भी है ना, अब you know the meaning of relaxation. You got the meaning of relaxation, right?
Distance plus weight.
If this is the case, what we do? This is what we did, right? In Dijkstra also. Is it clear? Relaxation. Sas, clear? Deva?
Yes, bro. Yeah, yeah.
Manan Deva? Yes,
So
no?
that
Yes.
is condition only, right?
Yes.
Yeah, yeah. Same relaxation, if condition. Whatever we wrote.
Mm.
Okay. So what Bellman-Ford tells you is, do this for all the edges. Do this for all the edges. How many times? N minus 1 times. N is nothing but number of vertices. Okay. So in this case, there are how many? 1, 2, 3, 4, 5, right? So you should do it for the fourth time. 4 times. If you do 4 times
Okay, okay.
this one, your answer is done. That's all. What thing should come to your mind? Why n minus 1? Right? Why only n minus 1? I mean, I should have written like this, mod v minus 1. So do you understand this notation? V is what? In a graph, number of vertices.
What is
So mod v is nothing
Mm.
but length, a number of vertices. So mod v minus 1, you should do it. Okay. So for, okay, I equals to 1, I less than or equals to mod v minus 1. Okay. I plus plus, relax. This is the code. That's all. Relax is nothing but go through all the edges and do it. Okay? No. So do you want me to write the code, or is it it's simple, right? What do you guys say?
No need.
Uh-huh.
Just keeping that fake above that if condition, right?
Yes, that's all. Here you should write if distance of, I mean, ये code, same code. This code. Oh, hello. Hello.
Yes, bro.
Uh, so there is a power outage. Okay, I might get disconnected.
Okay.
Okay, probably I will try to cover this. Yeah. So what I was saying is, we have this, and just keep this line of code here. So, and you're done. Okay. So the only thing you have to know is why we are doing it for this many times. Is someone having this doubt? I mean, ask, like, do you want to know why we are doing for n minus 1 times only? I mean, mod v minus 1. This is the crucial part. That's all, and nothing special in this. Okay. So, can I say when I travel all the edges? Okay. Let's say there is a graph like this. Okay. When I travel all the edges, can I say at least one node for sure will get relaxed? At least one node. Can I say that? Let's say we are starting from.
Yes.
What do you mean by relaxed? Relax means updating its distance. So can I say
Hmm.
in all the nodes, at least one node will be relaxed for sure,
Yes.
right? So let's say this is the node. This is the first time. After doing second time, can I say again one more node will be relaxed for sure? At least one node will be relaxed.
Yes.
So let's say this node got relaxed. Again, after doing the process for the third time, can I say maybe let's say this node will be relaxed, so at least one node, because every time you do, what happens, at least one node will be relaxed, right? Why one node will be relaxed? Because someone would have got their better distance, right?
Hmm.
So
Hmm.
now this got updated. Now again you will do it for one more time, and maybe this gets updated, not maybe this gets updated because of this, maybe, right? So at each process you have n nodes. Out of them, one node is obviously having a distance 0, right? And there are leftover is n minus 1 nodes. So if I do the process for n minus 1 time, can I surely say that I am done? Because each time one node will be relaxed for sure. So in n minus 1 times, n minus 1 nodes will get relaxed. So I am done. Is the intuition clear? Clear है कि नहीं intuition? अरे हाँ.
हाँ. Yes.
तो एक बार फिर से बोल सकते क्या?
Yeah. So Deva, there are n nodes, right?
Yeah.
Out of n nodes, can I say one node will be like having a distance 0, which is the starting point, right? So there will be n minus 1
Yeah.
nodes, right? So in n minus 1 node,
Yeah.
whenever I do relaxation for all of the edges, how many times I am doing? I am doing for n minus 1, v minus 1, right? So n is nothing but
Yeah.
here in our case. So can I say when I do relaxation for all the edges one time, can I say one node will be definitely relaxed for sure? One node, at least one node,
Yeah.
because someone will
Yeah.
give their better distance and you are done, right? So
Yeah.
if you are doing it for the first time, let's say this got updated. Again, you will do, and maybe one another node got updated, another node got relaxed. For the next time, the another node will be relaxed. For the next time, the another node will be relaxed. So in each process, one node will be relaxed for sure. Do you agree now, Deva?
Mm.
In one process, whenever you write a for loop, at each step, whenever you are writing this, can I say one node will definitely be relaxed? If that's the case,
Yeah.
how many times we are doing? We are doing n minus 1 times. And in n minus 1 times, n minus 1 nodes will be relaxed for sure. So this is the proof given by Bellman that if you do n minus 1 times, you will relax all the nodes. Okay, now is it clear?
Yeah. Yeah.
ठीक है, so
Yeah.
this is how Bellman 4 is. The next question is how to detect whether a graph has negative weighted cycle or not. Okay, simple. The same process, do it one more time, only one time. If if distance of v is, if you are getting this, what is the meaning? If you are doing it after n minus 1 times, and after the last time, I mean whenever you are doing for the last time after completion of this for loop, when you are doing for the last time, can I say again it is trying to relax? Hello?
Hmm.
Yeah, yes, bro.
Yeah.
See what Bellman Ford claimed is कि n minus 1 times में तो हो जाना, you should be completed with n minus 1 times, but when you are doing for the nth time and again if it is getting relaxed, can I say that there is a problem, there is a negative weighted edge now?
Yes, yes, bro.
Yeah.
So
Yeah.
after n minus 1 times, do it
Yeah.
again. If this condition holds, then there is a negative weighted cycle. That's all. Okay.
Okay.
So this is it for the Bellman Fort. Okay. So I'm not writing the code because it's pretty easy. You can check in Geeks for Geeks also. Very simple. Okay. Just writing ye wala,
Hmm.
these two lines here inside this.
Yeah.
So will you guys will be able to manage?
Yes, bro.
Yeah. For sure.
Yeah.
Sure. कितने questions हो गए? कितने? How many you have to do homework?
3.
3. One is multi BFS.
Okay. One is,
The third one is the Bellman Ford.
and second one.
Second one, the direction
Yes.
binary
Direction.
biparallel.
Direction.
ठीक है?
0.
0.
तो till Tuesday can I expect codes?
Yeah. Yeah.
Tuesday, yes.
Sure. Okay, so this is all about SSSP. Okay, the next and the last thing for today's class which we will learn is Floyd's algorithm. Okay, what is SSSP? It's that given a source node, you are trying to find the shortest distance from that source node to all the other nodes. What's Floyd algo? Floyd's algo is all pair shortest path. Okay, all pair shortest path. That is, given any two nodes, you have to tell the shortest path. Okay, trust me, this is just 5 lines of code. That's all, nothing else. Okay. So can anyone tell the time complexity of this? I did not discuss about this, but see and tell me. Outer loop कितने बार चलेगा at max? At max outer loop
B of V.
v into some
Big
inner
of
loop. Inner loop, what we are doing, we are iterating
V.
on all the we are iterating on what?
Neighbors.
Edges, no? Edges.
Edges. Sorry. Yeah.
Can I say this is the time complexity of Bellman?
Yeah.
That's all. What's ours?
Yeah.
Yes, bro. Yeah.
Okay. So the next algorithm which we will see is all pair shortest path. Okay. All pair shortest path is nothing but, okay, given some random again graph. Okay. कुछ तो एक graph दिया है. If you take any two nodes, again there is a weight obviously. Okay, there is a weight. Given a graph, you have to tell, given any two nodes, what's the shortest path between those two nodes. Okay, given two nodes u comma v, you need to find the shortest path from between these two nodes. Okay, is the clear? I mean, is the question clear? Requirement clear?
Yes.
Yeah. So in
Yeah.
previous cases, single source, but to all the nodes, right?
Yes, in the previous cases, single source all, but now all pair. I mean, any pair they can ask you. Okay.
Mm.
Okay. Now, if you don't have Floyd's algo, can you solve it via Dijkstra?
Yeah, we can consider all nodes as
Exactly.
sources.
Correct. So if you run Dijkstra from each and every node, can I say I am done? I can store distance array for all the nodes and I am done. Can I say that?
Yes.
Yes.
Okay. So the time complexity will be what?
Big
E in
of V into V into V.
E into log B for one of them, and you will cost extra one more,
For all.
right? This is the
Mm.
complexity. Okay. But yeah, I mean, this can be doable, but again, since there is something more better and easy to code, we have something as Floyd's algo. Okay. So Floyd's algo ka intuition is very simple. Okay. What Floyd's algo stating is कि if you are at node U, if you want to reach node V, what you do is you try to use all the alternative path, not alternative, you try to use all the existing paths. Okay. That is, there will be some nodes, right? Let's say node X, node Y, node Z, some node W probably. Okay. So what Floyd is telling is कि bro, try out all the possibilities. Try every node as an intermediate node and try to check whether you are able to reach at a better distance or not. Try all the nodes as an intermediate nodes and check whether you are able to do it or not. Okay? That's the Floyd's ka intuition. He given two nodes, try reaching to all intermediate nodes. Okay, try reaching to all intermediate nodes and try to reach the final node. Okay. Now this is kind of a DP solution and it's very easy. Okay. Let's say DP of ij will denote. Okay. You guys should tell me what it should denote. DP of ij.
Start to end.
Exactly. I mean, अच्छा से बोलो. Start to end मतलब पूरा definition बोलो. Question क्या है?
From
Age weight.
end,
Age weight from
start
node
node
and
to end node.
What's the question? Shortest path. So can I say shortest path from I to j? इतना ही
Yeah.
है.
Yes. Hmm.
ठीक है. So dp of ij will be nothing but min of already whatever you have, that is dp of ij itself. ठीक है. The another option, it got stuck. Yeah, the another option is try every node as an intermediate node. Correct. So dp of
Yeah.
I to k plus what it should be. Manan, try to tell this. मैं I to k गया.
K to I, K to J,
Exactly.
K to J.
And since okay, मतलब k can be all the nodes, right? मतलब we are using all the various nodes, right? So go and do it. ठीक है. ठीक है. Clear? Hello.
Yeah. Yeah.
Yeah.
Saad is thinking that
Yes, bro.
Yeah. Yeah.
I am just about to say something. Okay. Floyd algo. Java.
No, Rahul. Actually, I'm facing some network issue in between.
Okay.
Today there's a lot of lags today.
Is it from
Yeah.
my side? I mean, I switched to network. Still,
No.
Only that one note, one
One
note is
note,
lagging.
one-
You
Yeah,
the mark.
Not your voice.
not a voice. It's a one note that is lagging.
so should we shift to software?
Yeah, better.
We will call Satyanarayana and say him.
Hmm. Hire Abhishek. We will make much better software than yours.
Mm.
Okay, so what
Yeah.
we'll do is now instead of having let's take this adjacency wala thing. Okay, and we'll create a simple matrix. Matrix is what? uh, like, do you know this representation of graph? I mean, कैसे बोलूं? Like, so you can represent graph as an n cross m matrix also. Okay, n cross m matrix मतलब
Yeah.
like ith row and jth column का whatever the value, that means the
Wait.
weight from here to here. Okay, okay, so what we will do,
Yeah.
maybe instead of writing I can try to show you from here. uh, Code Floyd.
Adjacency matrix. Oh, Floyd Warshall.
Forget about the question. Okay, so can you see now we have something as edges 0 to 1 have a weight 3,
Hmm.
1 to 2 has a weight 1, 1 to 3 has a weight 4, 2 to 3 has something weight 1. Okay, this is the graph. Okay, so they will give you this one edges. Okay, so we create a Floyd, that is what, DP table. Okay, Floyd is DP table. See this code. If I equals to j, what does that mean? Distance from I to j, which is
Same.
distance from I to I. So can I say the distance will always be 0,
Yeah.
right?
Self node.
Self node. And if we have something, then please initialize with very high number as we do general. Is this for loop clear? Two for loops, simple,
Yeah.
straightforward.
Yeah.
Yeah.
Yes, sir.
Mm.
And finally,
Destination.
and what we do, so since they gave us these edges, please go ahead and create this.
Hmm.
Clear? Whatever they
Yes.
gave. U से V का weight इतना, बस खत्म.
Hmm.
And finally, what we do, this is kind of, you have to, I mean, not memorize. If you just see it once, it's done. See, for all the intermediate nodes, for all the pairs, dp of ij equals to min of dp of ij comma ik plus kj. बस इतना ही है. Is it clear?
Mm.
You can kind
Hmm.
of
Yes.
Yeah.
memorize for
Yeah.
now, like for the initial days, but as soon as you see, like, ये तो easy है ना, मतलब there's nothing to worry.
Correct.
Just writing for loop, 3 for loops, and updating it. This k is nothing but trying out all the intermediate nodes. That's all.
Intermediate nodes.
Yeah.
After this construction, Floyd of ij or dp of ij will give you the minimum shortest path from I to j. Okay.
Hmm.
In this question, they asked one additional constraint, so I have wrote something. But for today's class, this is what I need you to understand.
Yeah.
Correct.
Got it.
Yes. Got it.
Yeah. So this is it. Okay. Okay. Probably let's see this question once. I mean, read this question. एक बार समझ आ गया तो बढ़िया है. मतलब it's easy only.
Yeah.
The
Fine, bro. Verify reach with this path and some distance at most. Hmm.
So return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. Okay. So
Yeah.
as a you need to return the city which has smallest number of cities that are reachable via some path and whose distance is at most distance threshold. Okay. So what I have done is I have gone through each of the node. Okay. And I have gone through each of its matlab, sub pair. If I equals to j, that means obviously it's the same city, so we will not consider that. Otherwise, if the what is Floyd ij, can I say it's the distance between I to j? If
Hmm.
the
Yeah.
distance is less than or equals to distance threshold is dt, this one. Okay.
Yeah.
Okay, so if it is, can I say I got one extra city from node I? Okay,
Yeah.
so I got one extra city. If this extra city is less than or equals to limit is what? We need to find the shortest, right? Return the city with the greatest number. Sorry. If there are multiple cities, we need to return the greatest number. So if it is less than or equals to limit, okay, take this into consideration. Limit is nothing but कितने कितने ऐसे है कि like which are having less than or equals to threshold, and if this node has less cities than this, then please take this as an answer.
Yeah.
And this appeared, and this is a good question, I mean, for the beginner stage to try out. Okay,
Yeah.
and if you know Floyd IJ, you can write this. It's not hard.
Yeah.
Okay, clear, everyone?
Yes,
Yeah.
sir.
Forever.
Yes.